Hello, welcome back everyone. Hope you had a good break. Up next is Alvaro, a developer with 22 years of experience and a principal member of technical staff at Oracle Labs. Quite a long title. As a Micronaut committer, he's here to reveal what really happens when frameworks like Spring or Lombok process annotations, bridging the gap between runtime reflection and compile time magic. So please welcome him.
Good morning, everyone. Thanks for being here. My name is Álvaro Sánchez. I promise you two things. You will learn something new and you will have fun. Let me introduce quickly about myself. I'm coming from Madrid, as you can tell from my British accent. Hope it will be fine. I'm a Java developer, been always doing Java. At the moment, I'm working on Micronaut at Oracle or Oracle Labs, different parts of the framework. Oracle Labs is also the home of another project you may have heard of, which is GraalVM. And I'm not a developer advocate myself. I'm just a committer on the project, but I enjoy going to conferences when I can to speak about different topics. This is actually my third time at HipCon, so yeah, I'm looking forward to many more. I'm, as you know, as a conference speaker, I'm really proud of one thing, which is that I have never ever done any single talk about AI yet. But yeah, it's believe me, it's really difficult to to get into conferences nowadays without talking about AI. But yeah, let's move on. At a personal level, let me tell you something about me. I'm a runner. Yes, don't be surprised. I run a lot. I run applications, I run containers, and I run them very fast. OK, that's enough. Slides are available on Speaker Deck if you want to take a picture, not only this presentation, but many others. And in the meantime, let me ask a few questions about you. So who is using Spring or Spring Boot? Please raise your hands. OK, thank you very much. Exit is over there. Thank you. No, it's OK. Who's using Quarkus? Is anyone using Micronaut? You're a good guy. Anyone using anything else, like, I don't know, Helidon, Jakarta, or no framework? OK, that's interesting. You will tell me later what is that. No matter which framework do we use, we all use annotations, right? So if I were to ask this question, everyone should raise their hand. Annotation processing in Java is normally a two phases process. We first need to discover annotated classes, and then we need to do something about it. So let's think for a moment on a simple example. The transactional annotation. You probably all know how it works. You put transactional in a method, and then magically, the framework will handle the transaction boundary. The actual implementation is the proxy pattern. So mentally, it's really simple. You need to wrap around the method invocation to the actual method, right? So when someone is invoking the transactional method, it's not your method. It's a method of a different class, right? And that method has, at the beginning, the transaction creation at the beginning, then delegates the call to the real method, and then after that, based on the method results, will commit or roll back the transaction, right? What I'm going to explain you here is what are the possible options in Java to implement this, and how different frameworks will do that, right? So let's begin with runtime annotation processing, because based on what everyone is using is essentially what the Spring is using. In the case of Spring will use a technique called class path scanning. We are on the annotation discovery phase. We need to discover annotated elements first. And we need to do class path scanning. Throughout the presentation, I've included, I have a cursor. So I've included these warning icons to highlight things which I think, let's say in a polite way, could be done better, right? So class path scanning means that Spring will have to iterate over your classes. Imagine you're working on a project. You will have, like, your project classes will normally be exploded, but you also have jar dependencies on the class path, right? Spring will have to iterate over all of them. Your classes and your jar files, and for each of the jar file, each of the classes, right? Then using a custom class loader, we'll have to load the class into the class loader. And they need to do this because the next thing they need to do is to use the reflection API. Reflection API is a Java low-level API to basically query about class annotations and metadata and so forth, right? So they basically use the reflection API to say, okay, first of all, give me the annotations of this type, and then give me all the methods and attributes of this type. And then we'll use reflection again to query the metadata of all the methods and all the attributes for every single class in your class path, right? Remember, this happens every single time you run the application. Every single time, this is the process, right? We haven't even discussed the implementation part, right? There is a new Spring AOT module. Is anyone using Spring AOT? Right? There's only one person using it, and he's an IDE developer, so it doesn't even count. But my impression is that the Spring AOT is kind of the future direction where Spring wants to go. Spring AOT is an effort to basically reduce the amount of runtime operations they do to implement annotation processing, right? To essentially increase the startup time. Well, I will discuss later, explain later, which is the problem with this approach. Is there any other way to do it? Like, if you think about it, using the reflection API will require you to load the class into the class loader. Loading a class into the class loader means that you have to pay the price of the static initialization of the class, right? Right, even before actually using it, right? So there are like other libraries in the industry that are doing differently. One is ClassGraph. ClassGraph is a library used by, for example, OpenRewrite and possibly others. What this guy is doing is essentially they are swallowing the bytecode format directly, right? They will parse the class files, not load the class and then use reflection to query about it. But instead, they've implemented an algorithm to basically understand bytecode instruction, right? It is quite feature complete, and well, it is optimized, but again, this is happening at runtime, right? ClassGraph will tell you, without using reflection, will tell you, for example, the annotations of a class or of a method or something like that. Right? There is another library which is called Burning Wave Core, and it is a similar approach, right? It's a bytecode parser, and that's it. At runtime, there's no other way. You either load the class and use reflection, or parse the class file directly to about reflection API, right? There's no other way. Now, how do we implement the annotation logic at runtime, right? Again, I want you to think that this is happening at runtime and not at any time, but startup time, right? When you start the application. So there is a built-in capability in JDK available since forever, which is dynamic proxies. It is there is like an API, a Java API, to generate on-the-fly implementations for interfaces, right? And this is essentially going to generate bytecode at runtime and then load this bytecode into the class loader, right? But it's limited to interfaces. So basically, for example, Spring has a mode where you can force it to use dynamic proxies, but as soon as you use an annotation in a non-interface class, it will throw an exception. So it's very limited, but it's there. the most mature library to do bytecode generation at runtime is cglib. cglib is essentially used by Spring, and it allows you to generate dynamically proxies and any other classes at runtime, classes or interfaces or anything. It can even mutate. It can, they call it enhance, but I say mutate existing classes, right? Mutating existing classes is problematic, and we'll talk about it later. cglib is no longer maintained and is possibly outdated, but you don't have to worry because Spring is using a fork of cglib and they keep it up to date, so you're safe. And essentially, cglib and many others are using ASM. ASM is kind of the foundation library that everyone is or was using to do a low-level bytecode manipulation. It is low-level because you're not, the domain model is not about classes or methods or variables or anything like that, but it's about the bytecode instruction set, right? So you need to understand the bytecode instruction set to work with ASM. And then we have ByteBuddy. ByteBuddy is a much more modern library used by essentially everyone else, like Mockito Jackson, Selenium, Spock, AzerJ. All of them are using ByteBuddy. It has 3 modes of operation. There is a Java API that you can use to generate classes on the fly. They have a Java agent that you can attach to your build, and it will do the code generation there. And the other option is to use a Maven or Gradle plugin to do it during the build. But in either way, it will generate bytecode, right? It is fast, but considering this is happening at runtime, and API is very nice. There are many documentation and example. So it is, if I were to use like a runtime code generation, I would go with ByteBuddy, with any doubt. And then we have like the final option here, or the last option, which is the class file API. So the problem is that originally, OpenJDK was using ASM for bytecode generation, like for example, for dynamic proxies, or when you have the anonymous inner classes, or in some Lambda use cases, it also requires to generate bytecode at runtime, right? So basically, the Java virtual machine has ASM inside, ASM library. Now this is introducing a chicken and egg problem, in which, for example, in order to support a new language version, which ASM doesn't support yet, they need to do tricks, right? Because how can you have a new ASM version if the JDK is not yet released, and the other way around, right? So it was problematic. So what they did is essentially create a replacement API, which is a class file API. It's a new standard, and it's a replacement for ASM. So that's it. That's all the options that we have at runtime to do annotation discovery and implementation. So what's the problem with runtime processing? So first of all, class path scanning is slow. It's slow because it is I/O operations on your disk, right? You need to, framework will have to iterate over your files, your jar files. We'll have to open them and then extract the classes and everything. That's slow. Then reflection API is slow. It is so slow that frameworks will and libraries will have reflective cache, because you're not going to query over and over again which are the annotations of a class, which are the annotations of a method. You do that once, and then you cache that information in memory. But guess what? You're likely not only using Spring, but maybe Jackson. Very likely you're using Jackson. Very likely you're using Hibernate. And each of them have their own reflective cache for the same, possibly the same information, right? So if you have, I don't know, like an entity with a Jackson annotation, then you'll have duplicated information in memory, right? the more classes and dependencies that you have in your project, the more startup time and memory consumption of your application. And it is a linear dependency without limit. Sky is the limit, my friends. But we haven't stopped there, right? That's reflection and class path scanning is to discover the annotated elements. To implement the logic, bytecode generation is a CPU-bound operation, right? And bytecode generation is not the only thing that you need. It's bytecode generation and then class loading, because this new class generated has to be loaded, and everything happens at runtime, right? And finally, this will all make GraalVM native image support more complicated. It doesn't mean that it will not work, because GraalVM supports reflections, supports dynamic proxies, supports everything. But you essentially have to tell it in advance. Like, for example, if you're going to do dynamic class loading, you need to tell GraalVM in advance so that it's putting the class into the image. Otherwise, it's not going to be there, right? And let me tell you once again that this is happening every single time you run your application, right? So let's now talk about compile time processing. Going into the annotation discovery phase, we have a library called Yandex. Yandex is Java class file indexer. It is used by Quarkus. And it's basically used during build time. I'm making a distinction between build time and compile time because it is not the same thing. By build time, I mean everything that happens, for example, during your Maven or Gradle build, right? Whereas compilation time is one specific part of the build, right? But the build has more things, right? So Quarkus and Yandex are not compile time. It's not happening during compilation, but it happens during the build. They have which is called the build enhancement process, right? And what Yandex does is essentially during the build will parse all the bytecode of your application, right? And will collect all metadata about annotations and class hierarchies and all the information that it needs. It will persist that into a file, to an index file, which then Quarkus will load it at runtime and will use it to query all the information they need without using reflection, right? So this is like a trick to get the information they want without using the reflection. For implementing the annotations, they use different techniques, but essentially they are all based on Gizmo. Gizmo is a library to generate or modify existing classes, right? It has an API similar to ByteBuddy, right? So you can generate classes and then add methods to the classes and then add statements to the methods, etc. However, like using the Gizmo API, it's only for the more advanced use cases. For simple use cases, they have something called the Recorder API, where they let you put some annotations, and then during the build, they will run it, they will capture the bytecode, and they will essentially use that as a generated bytecode on the runtime, right? But any of those things are only relevant if you're writing a Quarkus extension, right? As an application developer, you don't have to worry about this. And finally, we have something called JSR 269. This was introduced in December 2006. So that is 19 years ago, right? Potentially we can have someone here which was born that year, right? So it's that long. So this is essentially defining an API in Java to do annotation processing, right? And I would leave the question for you, like, to think about it as to why popular frameworks, and by popular frameworks, you know who I'm talking about, Why didn't they use this approach originally, since it was available since so long time ago? But essentially, an annotation processor are compiler hooks for Java-C. This literally happens during compilation, right? And is the technique used by Micronaut, Lombok, MapAbstract, etc., right? Is anyone here using Lombok? Please raise your hands. Keep your hands raised, because I need to remember your faces. I will look after you later, right? So, annotation processing is part of the compilation and happens in several rounds, because during annotation processing, you can generate a source file with annotations that need to be further processed, right? So there will be some rounds. During annotation processing, you only have sources available, so there's no classes yet. They don't exist, right? There's no dependencies. There's no class path, compilation class path, right? There's nothing like that. You can have annotation processing dependencies, but they will be different. Like, for example, if during annotation processing you need to generate a YAML file, for example, you can have snake YAML on the class path, on the annotation processing class path, but it's gonna be different class path dependency than the compilation, than the snake YAML compilation library that you have for your application, right? Things we can do during annotation processing, you can generate source code, which is what MapAbstract and Micronaut do. You can generate new bytecode, which is the typical use case of Micronaut. You can modify, tamper with, alter, destroy existing classes, which is what Lombok is doing. I don't know if you realized the wording that I was using. Or you can do something else, like, for example, generate JSON, YAML, etc. Like, for example, decorate Micronaut. Micronaut will generate OpenAPI specification out of your annotations during compilation. Decorate will generate Kubernetes descriptors for based on your annotations, etc. Right? And now, my favorite part of the talk, which is our happy chili pepper Lombok, right? To explain why Lombok is a bad idea, let me first introduce you to the wonderful world of Java compilation. Java compilation is done on 3 stages. First stage is parsing. Parsing is essentially grammar checking, like a missing semicolon happens here. Once that's been checked and passed, the compiler will create AST. AST is abstract syntax tree, is an object representation of your code. So you have compilation units, and you have classes and methods and statements and conditional expressions and so on and so forth, right? And the AST is essentially what you get during annotation processing. You get the ASTs. As a result of the annotation processing, if new sources are generated and they contain annotations, and there is any annotation processor claiming those annotations, then we will have a new round. And finally, in the last phase, we persist the class to the file system. And it's also the moment where the compiler will do some optimizations, like, for example, custom folding, method inlining, etc. Right? So the annotation processing API does not allow you to modify existing classes because they don't exist yet. However, you have, like my favorite example in Lombok is toString, right? Is an innocent annotation, right? You put toString in a class. Then out of nowhere, like a toString method will appear on your class, right? And it's not the object's toString. It's like, it has like the actual implementation, right? It's printing the attributes. So how the hell is that working? Like, how is possible if Lombok is an annotation processor? The reality is that they hijack the AST, and they do that by using loopholes in different compilers, right? Then once they have the AST, they like inject, and I'm using inject as a bad word, like in SQL inject, right? They inject new statements or new methods or new things to your class, right? So that when the AST goes to the last phase, the compiler will persist it as if it was always there in the source, but it's not, right? And they use internal APIs and loopholes in different compilers. And the loopholes they use are different for different compiler vendors, right? So they have to do this process for Eclipse compiler, OpenJ9, it's going to be different, right? So let's go into the details of the problems of using Lombok. If you search on the internet about Lombok problems, you will search posts like, for example, what is the problem of using like a data in a JPA entity, right? You will have the lovely lazy initialization exception, right? But that's not my focus. My focus is to tell you like the technical problems, like compilation problems of using Lombok, right? First of all, it's using loopholes that will be closed. Like the OpenJDK team is aware of them. And the only reason why they are not closed already is because I often say that there are no Lombok users, but there are Lombok addicts, right? And you will have this, you will get mad against Oracle and will say, how could you do that? Lombok doesn't work anymore. Give me this back to me, right? So instead, what they do is they close, and every release they will close one by one. But the ship is sinking. The ship is sinking, right? Literally, get out of it while you can. It will be hard, like cocaine. It's hard at the beginning. When you try, you feel like you need it, right? But it's worth it, because if not, you will sink with the ship. So jump out of it while you can. Obviously, Lombok will limit your ability to upgrade a new Java version, because it happens quite often that after a new Java release, you try to use it, Lombok doesn't work, your tests are failing, God knows what, and then you need to wait for a new Lombok release to support it, right? Lombok mutates AST, which is morally bad, right? Is evil, but it's not only that, it's problematic because it will destroy other annotation processors, right? If Lombok runs after Micronaut, it will destroy what Micronaut generates. So Lombok needs to be run first. And yeah, AST manipulation breaks incremental compilation and incremental annotation processing, which is something you're going to enjoy only if you use Gradle, but it still will save some compilation time, right? And the main point is, come on, like Lombok was introduced in Java 6. The first Lombok version was a desktop installer because it had to copy itself into the JDK distribution to do their business, right? Obviously, the Java language in 2006 is not the same that we have today. We have much more modern building blocks, and like for example, I don't get the point of using data today. Add data, like you have records and blah blah blah. So please think about it, but remember my words that the ship is sinking. Sorry. Is anyone that never heard about Micronaut? Never? Okay. Just three quickly things about Micronaut. So Micronaut is a modern open source Java framework. And by modern, I mean that we started working on Micronaut, like the first release was in 2017. The team working on Micronaut is the same team that created Grails. I don't know if you remember Grails. Grails was a framework using Groovy, Spring, Hibernate, and a few other things. We spent 12 years doing Grails, and we learned quite a few lessons about what was right and what wasn't. We were fed up with 30 seconds startup time for a local application, or 1 minute or 2 minutes, right? Yeah, so we wanted to start from scratch and say, okay, we no longer have application servers today. We no longer have like Word files or ER files or stuff like that. Like the industry has changed. Can we do something differently? And can we do it without legacy, without all the legacy that traditional Java framework has, right? So that's what we did, thinking of serverless, the cloud, cloud native, etc., right? Micronaut is a general purpose framework. You can use it for all kinds of applications. People typically use it for REST APIs, but you can create a command line application, or you can create a headless Kafka consumer producer with no HTTP server whatsoever. And the third idea is performance. And by performance for us is an obsession. Not only peak performance or runtime performance, which is also, let's say, Micronaut is competitive in that space, but also two particular metrics that we believe will dramatically improve your developer experience. And those are compile time, startup time, and memory consumption. I will explain that later. The way Micronaut works is essentially a set of annotation processors that will visit your source code and generate, most of the cases will generate bytecode. We do that to basically save a compilation round. But there are some cases where we are generating source code because the users are demanding to see the sources of what we do. So basically, we generate all the framework infrastructure during compilation time using annotation processors, so that at runtime there's no reflection, there's no proxy generation, no dynamic class loading, and no class path scanning. We don't scan your class path, never ever, right? Those all things are basically the causes of runtime or startup time being large, right? You can think about Micronaut as like a multi-language compiler plugins. We support Java and Kotlin and Groovy. And its batteries included because we have many things built in so that you can get rid of other alternatives and reduce dependencies. Like, for example, bin introspections, which are replacement for the JDK introspector. We have bin validation API, a replacement for Hibernate validator, which is much faster to start and will consume a fraction of the memory, like 10%. Bin mappers as an alternative to map extract. We have micro-serialization, a drop-in replacement for Jackson with for Jackson data binding in this case. And it's going to be faster and more secure. You still can use Jackson annotations, but not Jackson data bind at runtime. Micronaut data JDBC as an alternative to Hibernate with compile time checks and queries. And this is all compatible with GraalVM native image since day one, unlike other frameworks, right? The only advice, well, let me give you two. There's two advices I want to give you today, and none of them is to use Micronaut. That's not the advice I'm going to give you. Two advices are remove Lombok, number one. The second one is reduce the number of dependencies of your application, and you will live much happier. And yeah, we can ship with a few annotations that will help you with this drug addiction of Lombok, right? But we will never mutate your classes. So I often get this question of I have a long-running service, I run it once and forget about it. So I don't care if it takes 1 second or 100, right? So it will be running all the time in production. So why it's matter? The answer is that you should be running your application a lot of times locally during development, right? There is a whole industry about mocking. And also this so-called pyramid of testing. Have you ever heard about the pyramid of testing? It's a like a concept or idea introduced by Martin Fowler in 2011, right? We didn't even have a Spring Boot, only Spring Framework, right? Back then. It's based on the idea that you need to write a lot of unit tests, and because they are fast, they're really fast to execute, then fewer integration tests because they are longer to execute and almost very few end-to-end tests, right? But this is biased on the technologies that were available back then. What you really, really, really want to do is run your application and not use mock MVC, mock this, mock that, mock the other thing, but grab an HTTP client and an HTTP request to your application using the real beans, using a database, and using like a no mocking and then make an assertion in the response, right? That's an end-to-end test, right? So developer productivity is the answer, or one of the answers, right? The second answer is cloud native deployment. So basically, in a cloud native deployment, like for example, in the cloud, time is money, right? Not only serverless. Serverless is like the book example of where this matters, right? But think about also Kubernetes. If you have pods that can come up instantly, you can consider in scaling almost to zero, right? And also, you increase the server density. You can get high availability faster with less resources, right? And yeah, you can use a GraalVM native image if you want to squeeze a bit more performance, right? I always like to end with the use case of Disney Plus, which is using Micronaut and GraalVM in AWS Lambda in one of their services because they made the numbers and they are saving a ton of money. So this is a QR code that I have with a small feedback form. It will also give you my social media details. And this is all that I have. So did you learn something new today? Yes? Did you have fun? Thank you very much.